Today we have learned about electric devices such as transistor, and as you can see in this page, this is the symbol of transistor, and it is consists of four parts. One is source, and others is drain, substrate, and gate. And this is the top view and side view of transistor. And for ideal transistor, each IV characteristic graph looks like this. And for real case of transistor, each IV characteristic graph looks like this. And we have the slope must be steep to act as like a switch. And next we have learned about quantum mechanics basic. And what we have to focus in this section is the concept of energy quantization, quantum tunneling, and light wave particle duality. And we will gonna deal this page later. And for semiconductor, it includes transistors, diodes, passive components such as RLC, and it applies to memory, logic circuits, and etc. And next I'm gonna introduce about Moore's law. Moore's law is the number of transistors in a dense integrated circuit doubles approximately every 2 years, and the law was defined by Golden E. Moore. And next, I would like to introduce about conduction, valence band, and band gap. And to explain simply, in a valence band, at 0 Kelvin, in this energy level, electrons is fully charged, and for the conduction band at the 0 Kelvin, electron is fully empty. And at the forbidden band, it also called as band gap, and there should not be any of the electron. And for next page, this is the band diagram of insulator and semiconductor and metal. And as you can guess, insulator has the biggest forbidden gap, and for the semiconductor, it is relatively small, relatively has small forbidden gap, and at metal, it almost has no forbidden gap. So its conductivity is better than any other of those two material. And this page is about crystalline state of solid, and there is 3 types of stage of solid. First one is crystalline, and second one is polycrystalline, and last is amorphous. And as you can guess in this picture, crystalline has periodic order, and for polycrystalline, it is not that periodic, but it has something better than something better conductivity than amorphous. And In amorphous, it has no periodic. And single crystalline is near perfect periodic arrangement. Polycrystalline is composed of many microscopic crystals. Amorphous solid is non-periodic arrangement. And this is the method of making a silicon wafer. And next I would like to introduce a PN diode. If we give negative forward bias, the energy barrier height will gonna decrease. So the more electrons in the conduction band will gonna go over the barrier height, and it goes to P-type semiconductor. And if we give reverse bias, the depletion will gonna increase and the energy barrier height will gonna increase, so no electrons go over the barrier height, and it is same to the hole. Thank you.